Works. All right. Good morning, Copenhagen. How are you feeling today? Good? Have you enjoyed the party yesterday? Karaoke? Did you sing something? A little? No? No? I did. All right, never mind. So we came here today to listen about the modern secure adaptive streaming on the web. So guys, as you may already know, media streaming is ubiquitous, right? We listen to our favorite songs while running or sitting on a train. We watch movies and TV series with family and friends. So nowadays, with the increasing number of content and devices, providers must keep pace and provide the most efficient and smooth playback to all users, no matter where they are, no matter what devices they use, no matter what content they listen to. They also have to stay compliant so that no content can be distributed without producer's consent and knowledge. So, if you've ever wondered how the world's biggest streaming companies stream their content, you're the right session. Because today, we are going to learn how the modern and secure adaptive streaming works on the web. But before we jump and start exploring, I will just quickly introduce myself. So, my name is Kasia. I'm a software engineer working at Spotify. My team and I develop an SDK that powers Spotify player on the web. So it's basically like a JavaScript library, or actually written in TypeScript, that communicates with the browser API. And yeah, I'm originally from Poland, but currently living in the UK. I love board games. I try to play board games like every now and then. And I also love watching movies and TV series, which, spoiler alert, you may actually guess from the presentation as well, because I have some images and GIFs as well. So, the agenda for today is as follows. First, we'll talk about the how to ensure a smooth and efficient playback. And here we'll cover some of the topics, such as segmentation, adaptive bitrate, dash protocol, and media source extensions, or MSE in short. After the theory part, we'll see all that in action. So I prepared like a part of demo. So we'll see how the adaptive bitrate works in action. Later on, we'll talk about the licensed content, where we'll cover the encryption and decryption processes using the encrypted media extensions, or EME in short. Later, we'll also see another like a demo part. So we'll see how to encrypt the content, how to decrypt it. And last but not least, we'll just wrap everything up and yeah, just summarize what we have learned today. So just so you know, I won't talk about the Spotify internals today, but rather a standard ways of how to basically stream media on the web. Cool. So, are you excited? Nice. Alrighty. So the very first part is to ensure the smooth and efficient playback. And this is the most classic examples that you probably have seen like many times, right? So we have the video HTML media element, we have a file, and we just assign it to the source attribute. And this is basically how it works, right? From now on, you can just click the button, you can like skip or like advance and so on, and basically it works. But this approach has two issues. And these issues are that we can't control overplaying fraction of data, and it doesn't support the bitrate switching. And these two are very crucial when it comes to ensuring a smooth and efficient playback. And what do I mean by these two criteria that I listed here? So when it comes to the first one, it's very important to play with just a fraction of data. And while current HTML media elements support that by making the range request to some CDNs and servers, it may be that the CDN or the server might not even support it. So in this case, the browser will try to download an entire file prior to playback. So in case if it's like a video, like a very high quality and long video, you may wait a while until the very first frame. Moreover, you don't have a control over how much data will be downloaded, because this is something that browser decides. So on one platform, or on one like browser, you'd like to, for example, download like just like a fraction of data, like maybe a few segments. But on the another, you maybe decide to download a bit more, or a bit less. So you don't have such control. So this is something that we like to tackle here. And the second thing is the bitrate switching. So bitrate switching, just to give you like the best real-life scenario. So imagine that you are sitting on a train, right? You're watching some video, and then suddenly your network connection drastically drops down. So you can see at this point that the video that you were like watching may be slightly decreased in the quality. Have you noticed that ever? Yeah? Good. So this is like on purpose. So the content providers try to switch between bit rates in order to fit your current bandwidth. So this is in order to avoid the stalling, buffering, or even completely stopping the playback. So this is where the adaptive bitrate is so important, because at least you can still enjoy watching the video without like stopping, okay, what then? What next? I have to wait how many time? No, at least you can like still watch it. So these are the two things that we'll tackle today for the first part of the presentation. But before we jump into them, I just wanted to mention two things. So first one is that I'm going to focus on the video files, like on the video like types of only, just to make things interesting. So during the demo part, I will have some examples of video, but overall, all the information that you will learn today, all the commands that you will see today, also apply to audio-only files as well. And the second thing is I'm going to focus on the MP4 format today, because it's the most common format used in streaming, and it's very easy to manipulate. So basically, if you, for example, after this session, decide to like a bit be geeky and try to play with MP4, and for example, remove some atoms and so on, which you will learn like in a few slides what I'm talking about, then you are free to do so, because there is like plenty tools out there online, being able to download on your local machines that you can just, download and play with that, which is super nice, by the way. And yeah, you can do. You're free to do so. All right. So for that, we have to start with the MP4 structure. So this is the MP4 structure, and MP4 consists of atoms. So all the peculiar abbreviations that you can see here are called atoms. We have the ftip atom, which is the file type. We have move atom, which is movie metadata. And then we have mdat atom, which is basically a payload of video or audio. And then if we decide to fragment it, because we have to somehow like split the file into multiple pieces, so there are some like intermediate steps to it, and this is the one. So if we decide to fragment it, we'll notice some big differences in the structure. And the first difference is that we'll get an init segment and a bunch of media segments. So in the init segment, we'll get the ftip atom that we had before. We'll get the move atom as well. But now inside the move atom, we'll have yet another one, which is called mvex. And this one stands for movie extends, and indicates that at least one of the streams got fragmented. When it comes to the media segment, it will have two atoms, move atom and mdat. And if you can notice, the move is somewhat similar to the move one that we see on the left-hand side. But it has like the F at the end. So this means that this move atom is specific for that fragment only. That's why it has like F at the end. And similarly for the mdat, it's also only specific for that given segment. Here at this point, it's worth to mention that the current segment doesn't have to know anything about the previous segment or the next one in order to be playable. The only information it needs is the init segment, and that's it. And this is how it looks in kinda reality. So I used one of the online tools that I'm going to show you later as well. And I took the Big Bug Bunny MP4 file and uploaded to the website. And it showed me what kind of atoms it has. So as you can see, it has the ftip, move, and mdat. And then once I use the MP4 fragment command from the Bento 4 tool, in order to fragment the file, I got something like this. So I got the ftip and move, which are the init segment that we have seen before. And then we have move, and that move, and that move, and that move, and that. So all of these are the media segments. And basically, I could yeah, there are like more of them. I could continue like that, but I don't want to be like you know, like all the broken record. But yeah. So at this point, we've just fragmented the file, which is great. This is like the very intermediate step that we had to do. This is awesome. But we still don't meet any of the two criteria that we just like created, right? That we just set up. So we still don't have a control over playing fraction of the data, and we still don't support the bitrate switching. And this is because even though we fragmented the file, it's still a single file. So what we have to do, we have to physically split it into multiple pieces. And for that, we have to use the streaming protocol. And these two are the most common streaming protocols out there. First one is MPEG Dash. Dash stands for Dynamic Adaptive Streaming over HTTP, and is developed by Dash Industry Forum. And the second one is HLS, that stands for HTTP Live Streaming, and it's invented and mostly developed by Apple. So today we are going to focus on MPEG Dash only, because we don't have like enough time to cover both. So we'll go with this one. And what we have to do, so we still have to fragment the file, which we already did. So this is the exact like structure we have seen before, which is great. And then there is another command from the Bento4 tool called mp4 dash. And this command will physically split all the files into multiple pieces, and it will also create the dash manifest. So it will look like this. So you can see there is like a stream MPD, which is the dash manifest. And then we have two folders, audio and video, for audio and video streams respectively. And now, this is the most interesting part. So if I enter any of the two folders, then I will see like a bunch of smaller files here. So as you can see, the very first one, the init mp4, is the init segment. And then we have like a seg prefixed other files, which is like seg1, then we have like a seg10, right? Because they are like ordered alphabetically. So at this point, we really split the file into multiple pieces. When it comes to the stream MPD file, this is the dash manifest that I told you. So this is like quite interesting file because dash manifest is an XML-based file, and it's a recipe, kind of recipe of how to play the content and where to find it. So the very root element is called MPD, that stands for Media Presentation Description. And you can find some information there like title, duration, and yeah, some other stuff. And then inside you may find like many other elements, which I'm going to explain right now. So one of these are the period. And there might be like one or more periods. Period is a time window within which we expect a content to be presented. So usually it's only one period, but if there are many, then it's actually easier to support dynamic content insertion, such as ads, for example. But usually there is only one. Then inside the period, we may have one or more adaptation sets. And the adaptation set is like a representation of a given content. So for example, if we think about the video content in this sense that we are like, talking about, video can have two streams, right? Because it has like a video stream and audio stream. So video is the frame, right, like the image, right? And we have the sound as well. So we have two streams. So basically, those two streams will be described in two separate adaptation sets. So this is basically what the adaptation set is about. And inside the adaptation set, we may have one or more representation element. And representation is like a version of a given content. And the best use case to give you when it will be used is when we start supporting the adaptive bitrate, which we'll also see in the next few slides. So this is basically when you may see like many representations here. So this is like the overall structure of the Dash manifest. And here I will show you how it looks in reality. So as I said, it's XML-based file. The very root element is MPD. Inside, we have one period. Then we have two adaptation sets, one for video stream and one for audio stream. Then we have one representation in each, which basically means that at least at this time, we only support one bitrate, because we only have one representation, so only one bitrate. And in terms of like, in the very beginning, I told you that the Dash manifest is like a recipe of how to play the content and where to find it. So here I highlighted some information of how to play the content. So as you can see, I have the MIME type and codecs highlighted. And these two information I will use later to create the HTML media element, which you will see in the next maybe 2 or 3 slides, really. When it comes to where to find it, here I highlighted other fields as well. So we have the segment template here, and we have 2 fields, like initialization and media. So basically, we have the ID highlighted a bit below as well. So if we replace the representation ID, for example here, with the ID that I highlighted below, then we'll get an exact path to the init segment, which will be video/abc1/init.mp4, and then wherever it is stored, it should just get the very first init.mp4 that we have here. And the same, of course, applies to media segments that we have here. Instead, we also have to put some numbers, so we have to know which segment to download. Cool. So this is like the Dash manifest looks like. And in the very beginning, we saw like these 2 examples, right, with the video HTML media elements, which are the most common ones, as I said. The problem is, right now, we just took the file and we split it into multiple ones. So these 2 won't work anymore for us, right? It's not like we can just take the files and we can just, pull it out and assign it to the source attribute. It won't work anymore. So in this case, what we have to use is the media source extensions, or MSE in short. What does that mean is that we still have to create the HTML media element, and we still have to create the media source, but it will be an object in this case, and we'll assign it to the source field of the video element. And then, once we have done that, then we create a source buffer and assign it to the just created media source. And as you can see, while doing so, I have to check the MIME type and codecs from the Dash manifest that I just showed you like a second ago. And after that, once I created the source buffer, then I can actually start fetching the segments and append them to this just created source buffer. And basically, this is how the whole playback works from now on. So we don't need the source attribute anymore that we have seen before. Now we're using the media source extensions, and basically it works. Cool. So for this part, we can at least say that we have a control over playing fraction of data. Because at this point, we haven't only split the file into multiple pieces, so we don't download only like a fraction of data by meaning the segments, but we also have a control over it. So we can decide, okay, so once you start the playback, you can, for example, download only 5 segments or 10 segments, depending on the platform, depending on the browser. It's really up to you. But we still don't support the bitrate switching. And in this case, we'll have to do some additional steps here. So in this case, we'll have to create like many files with, not maybe many, let's say 5, with different bitrates. And for that, we'll have to use one of the tools. For example, in this case is FFmpeg, that allows you to encode the file with different bitrates or with different codecs and so on. So what we are going to do here, we'll take the file, the original file, which is the Big Bug Bunny MP4, and we'll encode it with 5 different bitrates. And in this example, you can see that I have the 360 kilobits per second for video, 64 for audio, and then basically I expect the Big Bang Bunny 360p MP4. So this is how I encode like a file with different bitrates, and I'm doing it 5 times with 5 different bitrates. Then I'm taking all the files that I just created, and I have to fragment them, just like we did like in the previous slides. Once I have done that, then I take the mp4 - command again, that we've seen before, and this time we take all the previous files, all the previous fragmented files that we've just created. So as a result, we'll still get the stream mpd file, which is the Dash manifest with 2 folders, audio and video. But now if I enter the video folder, then I will see 5 different folders. So there won't be like a bunch of files that we've seen before, but 5 different folders because we have 5 different bitrates. And now if I enter any of these folders, then I will see a bunch of files that we have seen before, which are again the init segment and the media segments. When it comes to Dash manifest, do you think that did it change? What do you think? Yes? Here, no? Well, you're kind of right. It did change. So as I said, previously we were having only one representation element, and we were supporting only one bitrate. But right now, since we had like 5 different files with 5 different bitrates, now we have 5 representation elements. So in this case, depending on the current user bandwidth, the provider can serve the content from a given location, which is like a video AVC1/1 or /2 or /3, or maybe back to 1 if we like enter the tunnel. So yeah, at this point, yeah, so basically the Dash manifest has changed a little as well. And yeah, at this point, we can say that we just supported the 2 of the criteria that we just set up in the very beginning. So we have the control over playing fraction of the data, and we also support the bitrate switching. So these 2, as I said, are very crucial to ensure a smooth and efficient playback. So it seems like it's smooth like a pudding, huh? I guess so. So that was the theory part, and now it's time for a demo. All right, so let me just quickly switch to this tab. Do you see everything very well? Yeah? Cool. So just to explain you what I have here. On the left-hand side, it's my web application that I created specifically for this presentation and for this demo. And on the right-hand side, we have DevTools, of course, because I'm going to show you some network and also console logs and so on, which are quite interesting. Here in this part, this is like my terminal, and this is where the demo is. So basically, we are going to prepare the content, which will be later used in my application that I prepared. And also in this tab, I have one of the tools, which I'm going to just show you, just like, yeah, because it's cool. So you can see how the atoms look like. Cool, so let's go to the bitrate, because this is the very first part of the demo. And as you can see, nothing is here, right? I mean, we have like one error. If we go to the DevTools, yeah, 404, nothing found. Yeah, I think it's bigger now. Yeah, so nothing works. And it actually makes sense, because if we look at my terminal here, so this is the public. This is the folder where we will store all the content. Obviously, it should be somewhere on the CDN and so on, but yeah, I made it like more simple. And here I already prepared some of the content, which is the Big Bang Bunny fragmented, and we have 2 folders, like for the bitrate part and for the encrypted. So if I go to the output bitrate, you will see that we have 4 files already prepared, and there is like one missing, because we said that we are going to have like 5 different files. And as you can also guess, there is no like Dash manifest MPD file. So this is why the whole like application doesn't work at the moment. So this is what we are going to do now. We are going to create one more file. We are going to create a Dash manifest out of it. And we are going to also split all the files that you can see here, including the one that we will create, into multiple pieces, so that we will try to make this app working again. But before we do so, I just wanted to show you this tool quickly. So here I made like some screenshots that you could see in the presentation. So just to show you, I have the Big Bug Bunny MP4, and you can see that we have only 3 atoms here. But if I open it again and get the fragmented one, then you will see that we really have like many atoms here. So yeah, I didn't. Yeah, what I wanted to say? Never mind. Okay. So yeah, you can just test it out, basically. Cool. So this is the app. We have the 4 files. So in order to create like one more file with one more bitrate, which will be 360p in this case, I have to use the ffmpeg tool. And this is the command that you have seen before in the slides. So I will run it just now, and I will also explain what it contains, what options it has, because it takes a while. Cool. And go up, go up, go up. Cool. So as the input, I provided the Big Bug Bunny MP4, which is the original file that you have seen. Then I provided the 360 kilobits per second for video, 64 for audio. I provided even the resolution. And as a result, I expect the Big Bug Bunny 360p MP4. And I left these 2 options at the very end, because I guess these 2 are the most important when it comes to supporting adaptive bitrates. So what these 2 options mean is that the 48 number is the number of the frames. And given that the file is, the frame is 24, 48 means that we expect the segments to have the 2-second like a length. So it's very important to provide these 2 options here, because we like to sync the segments between the files. And what do I mean by that is that when you switch between the bitrates and the quality, you don't want to have any glitches. You don't want to have like any jumps, right? So this is like very, very important to have all the segments aligned and have the exact same length. So by including these 2 options, you will get this. So if you want to do it, then you will get the glitches, and it will be like a very ugly playback. So don't do it, basically. Cool. So if we go to the bottom, it has finished, which is great. Now we have to run the MP4 fragment command. So I'm taking the Big Bug Bunny 360p that I just created, and we expect the fragmented option of it. So I will do that now. And here we now have like 5 files fragmented. So at this point, if I run the mp4 dash command, I have to include all the files that I have here, all the fragmented files. So including the 360p, as well as the 4 others that I have already prepared. So if I run it, then as a result, I get the output folder. So if I enter the output folder, then you will see the stream.mpd file with 2 folders that we have seen before in the presentation. And let's have a look at the stream.mpd file first. So stream.mpd file. So as you can see, it is MPD XML-based file. We have like many representations here. We have like 1, 2, 3, 4, 5. So it's really there. We have one for the video stream, which is just here. We have one for audio stream, which is just here. So basically, anything that we have seen in the slides is basically replicated here as well. And interestingly, if we go to the video, avc1/1, we'll see like 5 folders, just like we expected. And if we enter any of these, for example, the 1, you will see like a bunch of smaller files that I showed you in the slides as well. So we have the init and the sec prefixed files. So what we did really split the file into multiple pieces. So now, fingers crossed, the application should work. And kinda is working. I mean, we can see like some segments being downloaded, which is great. So in this case, I'm starting with the lowest possible bitrate. And if I, for example, switch to one up and play the video, it's playing. Yeah, this is a very nice video, by the way. Yeah, so as you can see, the video works, right? We saw that the very first segments here were downloaded from with the lowest bitrate, but the next ones, which are here, have the one up bitrate. So let's have a look at the network then, maybe. If we go to the network, and we'll open, for example, the very first segments that we had here, for example, this one, you will see that we have the output video ABC1/1. You see it? Yeah, it's visible? Cool. So this is like the location, right, of the segment, ABC1/1. But if I take like another one, for example, this one, then you will see that it's coming from ABC1/2. So it is really served from a completely different location. So once I switched the bitrate, it was really coming from a completely different location, so it had completely different quality and so on. Maybe it wasn't maybe like a really like a noticeable because it's like very next to it. But if I would switch to like the very like high quality and with the very big bitrate, then maybe it will be like more visible. But for the human eye, it's not like super visible in this case. Cool. So that was the first part of the demo. Now let's jump quickly back to the slides. And let's talk about the licensed content. So in this part, we'll talk about the encryption and decryption. And encryption overall is very important because the content providers can stay compliant. And before we basically start like talking about these two processes, we have to go over like a few core concepts. And fortunately, there are only like 4 of them, so I won't bore you. And the very first one is called DRM, and it stands for Digital Rights Management. So basically, it's a technology used to protect the content from unauthorized use and controls its distribution. And there are 3 most common DRMs out there, which are Google Widevine, Apple FairPlay, and Microsoft PriReady. Then we have EME, that stands for Encrypted Media Extensions. And this is the API that basically decrypts the content for you. So it kind of sits in between of your web application, like your player, and also the CDM module, where CDM module, in fact, is the content decryption module, and this is the one that really decrypts the content for you. So it's like it's a software, it's like a binary, it comes together with your browser installation, and yeah, basically it's not open source, you can't see what is inside, which is kind of obvious, given the functionality it has, but this is the really one that the heart of the whole like decryption process. And last but not least, we have the CNC, that stands for Common Encryption. This is the standard encryption scheme that is supported by all DRMs. Cool. So these were the 4 concepts. And now let's talk about the encryption process. So here we have, again, the MP4 structure that we have seen before, which is already like fragmented. And as soon as we decide to encrypt it, we'll notice some very slight, maybe some very small differences in the structure. And what I mean by that is that we'll notice some additional atoms here. And one of these atoms is called PSSH, that you can see in the init segment here. PSSH stands for Protection System Specific Header, and it contains IDs to the keys that will be used to decrypt the content. So if I go to the next slide, this is like the example again from the tool that I showed you online. And this is like the normal init mp4. And after running the bottom command that you can see below, the mp4 dash, that this time it also not only split the file, but also encrypts it. I got something like this. So the init mp4 now contains the PSSH atom, which loosely translated means that the stream got encrypted. So basically, this is how the encryption works. You can check it out later. You can see the atoms, what are there, because they changed a little. But there's basically one command here. And now when it comes to the decryption process, when it comes to the encryption again, we have the dash manifest. And it has changed a little as well. So here we have the content protection elements. And we also have the PSSH here, which is the base64 encoded information about the IDs that I told you before. And now it's time for the decryption process. So here I wanted to stop for a second because I wanted to mention that the next few slides are going to be slightly more complicated and complex. And this is because I wanted to go over all the steps, all the methods that are included in the decryption process. When I was reading the specification about the decryption, I was finding it a bit not well explained in some places, and I was very often lost. So I wanted to take this opportunity to go over all the functions or all the methods that must be called, to explain you also all the parameters that they accept and all the objects they return, so that if you would like to replicate it on your own, it will be just as easy as doing everything that are described in the slide. So keep focus, but if you miss something and if I confuse you at some point, don't worry, because we are going to repeat it again during the demo part 2. Cool. So that being said, for the decryption process, we need 5 different components. And on the left-hand side, we have the red components. And we have the CDN, the license server, and the web application, which is basically the player. So all of these red components are created and basically maintained by us. So this is our own components. We have the CDN, where we store the encrypted content. We have the web application, which is our player. We have the audio and video elements. And we also do have the license server, which will serve the licenses that contain the keys inside. On the right-hand side, we have the 2 green components, which are out of our control, right? We have the browser, and we have the content decryption module that we talked about. So this one comes with the browser installation. So in order to play an encrypted content, we first have to fetch it from the CDN, and then we will attempt to play it. At this point, browser detects it's an encrypted content because it has a synth atom. So if you remember, I told you after encryption, we'll get some additional atoms, and this is again another one of them. And synth atom stands for protection scheme information. So basically, once this atom is detected, the browser emits an encrypted event. And this is basically where the whole process of encryption, or rather decryption, kicks in. So what we do on the web application side, we call the request media key system access method. And we provide 2 parameters there, which are key system and a list of configurations. The key system is a generic name for the content protection provider or the decryption mechanism. And it's usually a reverse domain name. So as you can see, it's com widewine alpha. And then the list of configurations. Here we just provide a list of configurations. So what we basically do here, we ask the CDN module if they are supported, if the key system and at least one of the configurations is supported. And if they are, then we get the media key system access object back. Once we get it, then we are interested in this method, which is create media keys. So we call it. And as a result, we should get the media keys object back. And this object is quite interesting, because this is a representation of a content decryption module. So this is almost like the only way how we can communicate with it. And it has two methods. The set server certificate, which will be used to encrypt the messages that will be later sent between the CDM module and the license server here. And we also have the create session, which is like, yeah, as the name suggests, to create the session, within which we'll obtain the keys to decrypt the content. So before we do any with these methods, we first have to take the media keys object that we got, and we have to assign it to the video HTML media element. And by the way, are you still with me? Yeah, good, nodding, I like it. Cool, so once we have done that, then we can actually go back to the media keys and we can call the create session method. And this method has a parameter, accepts a parameter, which is like a type of the session. And by default, it's temporary. So if you won't provide anything, that's fine. It will just create the temporary session for you. You can also create the persistent type, but it requires like a higher level of security. So we'll stick with the temporary one here. And as a result, we'll get the media key session object back. And here I highlighted like the three methods that we are the most interested in. And at this point, what we do, we'll take the generate request method, and we will call it with two parameters. We have the init data type and init data. And these two are coming from, they're coming on from encrypted event that we received in the very, very beginning. So all of these like methods you can see are somehow like, entangled. So for the init data type, as you can see, we have the example of CNC, that was the common encryption. And we also have some init data. So we take both and we just pass to the generate request method. What happens later, this request is provided to the content decryption module. So content decryption module at this point realizes, okay, so I got a request to decrypt the content. So for that, I need a key, right? So in order to decrypt the content, I need a key. So yeah, hey, I need a key. So it emits a message event, which loosely translated means that the key is needed. This message is then emitted by the browser. And on the player side, what we do, we listen for such messages through the onMessage event handler. So once we receive that message, then we make a post request to the license server. And if everything goes well, we get like 204 and so on. We get the license back. And the license here will contain the keys to decrypt the content. And it's also very important to mention that the license here is like obfuscated. So if we will look inside the license, we wouldn't really understand what is inside. It's basically understandable only by the content decryption module here. So once the player got the license here, it takes the license and provides it to the content decryption module through the update method from the media key session. And once we have done that, then the content decryption got the license, then it can take it, unwrap it, take the key, decrypt the content, or rather the frame, and provide the decrypted frame back to the user so that they can enjoy playing video. They can now see the frames, sound the music, hear the sound, and all that stuff. So from now on, everything basically works. So yeah, lots of talking, as I said. It was quite complicated and complex, but hey, we did it. So yeah, we can now dance just like Joey and Chandler. Cool. So we've just went through the theory part, and now it's time for an action. So I'll switch quickly to my terminal. And I will go to the encrypted part here. And again, as you may expect, nothing works. We have an error. If I go to the console, I have almost like the same errors that I had before because I don't have any content there. So if I go up to the output bitrate, let me just quickly do so. Come on. Where I am, video. Oh, I should use like a shortcut or something. But all right, we are almost there. OK, output encrypted. Right. As you can see, nothing is here, right? There is no files. There is no dash manifest. There is no folders, no files, basically. And it makes sense because it breaks. It's broken. So in this case, I'm going to use the mp4 dash command. But this time, I'm using the wide wine header, which means that we are going to encrypt it with the wide wine DRM. We have to provide some encryption key. And in the input, I'm providing the Big Bug Bunny fragmented MP4 in this case. So if I run it, then I got the output folder this time. So if I go inside, we'll see exact the same like result that we have seen many times already, which is the stream MPD and the two folders. I won't go into the folders because they all look the same, but the stream MPD is quite interesting. So as I showed you in the slides, now under the video stream, we have the content protection elements, which means that video stream in this case got encrypted. And the same goes with audio. So if we see at audio as well, it also has the content protection elements here with the PSSH information. So at this point, moment of truth, if I refresh the page, seems like it's working. At least we don't have any errors. But before we test it, let's have a look at the console logs. So this is what I promised to you that we'll go over like quickly again over the whole process. So I added some console logs that you can like see. The very first part was that browser emitted the encrypted event. Based on that, we called the request media key system access method with two parameters, key system and the list of configurations. As a result, we got the media key system access object back. And then we call the create media keys method from this object. So then we got the media keys object back, and we had to assign it to the video HTML media element. Then what happened is that we called the create session with the temporary parameter. We got the media key session back. And from the media key session object, we called the generate request. So that was the point we asked the CDM module to basically decrypt the content for us. So the browser emitted message event, which means that the key was needed. We listened on for this message in the onMessage event handler. So once we got this message, we made the post request to the license server. We obtained the license with a key inside, and then we provided this license to the content decryption module through the update method of the media key session. And yeah, now if we play it, it works. Cool. OK. So it works, which is amazing. And again, that was like only that for the demo part. So if I switch quickly to the presentation, I will just quickly wrap it up. So today we have talked about like how to ensure a smooth and efficient playback and how the encryption process and decryption processes work. So in this case, we have learned that it's very, very important to being able to play with just a fraction of data. And it's very also important to have a control over it. And segmentation and adaptive bitrate are overall very useful because they help us to minimize the risk of stalling, buffering, or even completely stopping the playback. When it comes to the encryption and the DRMs, DRM is very important because content providers can stay compliant. DRM is used to protect the content from unauthorized use and controls its distribution. And thankfully, we have EME, that is encrypted media extensions that help us to decrypt the content with using the content decryption module. So if the content got encrypted, at least we can always decrypt it based on some rules, like some scopes of the user, for example, and so on. So it's doable. So at the same time, while we are compliant, we can still serve some content to the users, which is like the main goal. So before I finish, I just wanted to share with you like a few resources. On the right-hand side, I used some of the tools today during the demo. So if you're interested in playing by your own, you're free to do so. As I said, they are like available online, or you can download them on your local machine and just play with that. On the left-hand side, I mentioned the specifications. The two specifications on the top are like maybe the most interesting in terms of like I use them to create the presentation and also the demo part. So they talk about the EME spec and the MSE as well. But I also included two other videos from YouTube, which I found quite interesting. So if you are more interested how the MP4 looks like, how to play with atoms and so on, I encourage you to watch the last one on the list. And if you are interested in the codecs, like encoding stuff, then the third position is quite cool as well. So that being said, in the top right corner, I shared a QR code with you. So basically, the web application that I demonstrated today is available on my GitHub account. And if you scan the QR code, it will take you directly to my repository. So feel free to clone it or to fork it and basically play with it. There's like a bunch of instructions that you can use, which are basically the same that you have seen today. So you can either rewatch the whole presentation, or you can just go over the instructions there. And yeah, that being said, thank you very much for your attention and for coming to my session. I know it was like early in the morning, and yesterday we had like a huge party here. And yeah, that's why I'm even more glad that you came here today to listen about the media streaming. So yeah, if you have any questions, I'm happy to answer any of them. Or if you'd like to catch me, I will be like walking around. I'm like visible person to talk to, especially when it comes to like this IT stuff. So yeah, really just approach me and I'm happy to chat. So yeah, thank you very much. So, any questions? Oh, there are some. Maybe here and then we will go there.
Yes, I just have a question about your work in Spotify. How many bit intervals are you working with?
Sorry?
How many bit intervals are you working with in Spotify for the songs? The bit rate?
Right, how many like bit rates we have?
Yeah.
Okay. I mean, it's not only 5, as I showed you today, that I can tell. It's like, it's a different number. I'm not sure if I can really tell it, but it's not the 5. 5, it was like just an example to show you like, I read in one article that 5 is like a quite good number to start with, but of course the more like bit rates you have might be the better in terms of like you can switch and really fit into the bandwidth of the user. And also like depending on the platforms and so on, then one bit rate might be better than the other. So it's better to have like lots of options. Not maybe lots, but yeah, more than 5. Then there was like 2.
All right, so if you have like an audio track with different languages supported, is that same concept as with bit rates? You just have different representations, or how does that work?
This is a very good question. So you remember, like maybe from the MP4 structure, I should maybe have this slide as well. So when it comes to the file can have like encoded text as well inside. You may have like a video track, you may have like audio track, and you may have also the text tracks, which will include the different like languages. So in terms of like bitrate, so maybe I will tell you something. So the Dash manifest and the bitrates that you could see here, I use the Dash protocol and the Dash protocol because, like as I said, it's one of the most common ones. But the most interesting part about the streaming protocols is that you don't have to really use any of those. In the FFmpeg tool, you can actually use one of the commands that is available there. You can split the files by yourself and then create the manifest on your own in the JSON file or XML or even in the text file. It's really up to you. So while having those, you can specify like the locations to the files because that will be up to you, and also the locations to the languages. So yeah, it's really like flexible in this case. I just went with the Dash protocol, and I mentioned the HLS because they are like the two most common ones. But there is nothing to stopping you from using your own streaming protocol because it was just like a file here. So yeah. And there was like one, yeah.
So in terms of, from the perspective of the browser, what's the difference if you're doing live streaming where you don't know the full length of the video when you start playing it?
And this is a really good question as well. And I must say that I don't really know the answer for that because as you know, like at Spotify, we usually have like a content that is like finite. So when it comes to like the Dash manifest, I know that it kind of supports the live streaming, but I wasn't like testing it myself. So I'm not really sure how it works, but I assume it will be something like the structure of the Dash manifest, and the content will be somewhat similar to it. But I don't really know the details. But that was a really good one. Maybe I should like reread it. Any other? If not, then yeah, thank you very much again for your questions, and see you around.